guys, well it looks like I'm back at the solid state relays. This is the one that died the minute I plugged it in. The start, as you can see, there's not much heatsink compound on the actual chip itself. And then you got this on top of it. So it wasn't really made to take that much abuse, to tell you the truth. This is the one that died the minute I turned it on. I got it working again. One thing I did notice, and for reference, anybody has the same ones that blow up on them when they turn it on. In this area right here, you have to resolder all this area right here. There was like 1, 2, 3, 4, 5, 6, 7 bad solder joints. Now I mean bad. After I fixed the solder joints and replaced the FET, it fired right up. The light came on, and it's been tested. If you put it on tone, it is working again. So the one that's on my bike blew up, same way this did. The light doesn't even come on, so I'm guessing it's solder joints again. What I'm going to do, since it's such a crappy build, basically going to take all the FETs I can, put them on this heatsink here, we can see that, put them in a row, and then I'm going to wire them in parallel so it distributes the load. So if one of these are designed for 50 amp, there's 50, 100, 200 amp load, and then I'll run 2 thick wires onto the board. Well, actually, I only need to run one wire out of the module itself, as you can see on this circuit right here. These 2 here go to the post, so what I can do is I can run 2 wires, negative and positive, off of this, and then just put some ring things on it and just bolt it right to the wire, right to the connectors there. Don't just directly solder it in, or I can directly solder it in. I could mount this like this or something. But this isn't going to work for me. Even at 50 amp, I still blew it. But then again, I don't know if it was the FET or was it the bad soldering job. Like, I'm going to go over the whole board. But that was hilarious. I couldn't even get the light to come on, and then the minute I reflowed some of the solder, it came on. So that just shows you how bad the build is in these things. So that's what we're going to do. I think I'll probably mount it like right here. Yeah. I'll epoxy it right there and then run the leads down. Yeah, I'll make it all one piece. See how it turns out. Okay, we'll see if this works. I got the negative and positive, black and white, and then I got the lead that controls the FET, switches it off and on in green. I'm going to basically leave it like that, and just glue it or strap it to it like that so you can actually see the electronics, or put it like that, and we'll go from there. And then I'm going to run the leads down and then run them in parallel all the way across. So I'm going to do that now. I'll save you from the boring part. That's about it. I'm not going to shrink wrap any of the legs. I've already tested, nothing shorting. But I'm not going to shrink wrap the legs, because if it doesn't work, I'm not going to, waste my shrink tubing, basically. But so each one of these is 50. So, do the math. 50, 100, 150, 200. 200 amp at 200 volts. There's no way I'm going to blow this up. If anything blows up, it has to do with the inside of this. So, as you can see, it does work. Everything's been resoldered, so all I can do is hope for the best. But the other one on the bike is totally fried. It's dead short, which isn't too bad. At least it got me home, but it blew sparks everywhere. So we'll see how this works out. Later.